Okay, this is lesson E. We are now going to create equations in general form. Again, solving for A from graphs and coordinate points. So, first thing we're going to take a look at is some factoring. So, we're just going to remember how to factor because we love to do factoring. When we have a trinomial, there's three things we can do. First thing we want to look for is GCF. Do we have a GCF in the first one? No GCF. So then we're going to go to a diamond. So if I diamond this guy, I'm going to take A times C, which is a 6 on top, 5 on the bottom. Now when we do a diamond, you always factor the top number. 1 times 6, 2 times 3. And you find the two numbers that multiply to give you 6, and they add to give you the bottom number B value. So we're going to have 2 and 3, they add to 5. So those become the numbers in your brackets. So we're going to have x plus 2 because 2 is positive, and x plus 3 because 3 is positive. Now, those are just factors. Those are not the x-intercepts. If I created an equation by going equals 0, and I said, what are my x-intercepts? I would say x equals -2, and x equals -3. Okay? This one we would also do a diamond on. -8, +7. Factors of -8, -1 and 8, -2 and 4. Now the reason I made my small number negative is because when you've got a negative on the top here, the sign of the bottom one, which is a positive, that tells the large number to be positive. Okay, so whatever sign this guy is, the large factor is the same sign. So that means I'm using 8 and -1. So -1 and an 8. And those are the ones that are going to go into my brackets. X minus 1 and x plus 8. And again, if I created an equation by going equals 0, I would pull them out of brackets now. So now I get x equals 1 and x equals -8. Okay? When you've got a coefficient for every term, you have to first of all look for a GCF. Ironically, there is no GCF that's going to come out of the third example. So we are back to diamonding this one. But remember, this is now going to have an A value of 2. So when you've got an A value that is different from a 1, that's where you have to open your brackets, and they start with either 1x and 2x. Because there's only two factors that create a 2. And that's going to be 2x and a 1x. Those are going to be the only things that are going to multiply to give you a 2. So you will factor the 2, and that's what will start both your brackets. Okay? That also means whatever you put on your sides of your diamond here, they're going to divide by those factors of 2 that we just wrote down. Okay? That's an important part. So we're going to multiply our A times C. We're going to get -10, and our B value is a -9. So now we're going to factor our -10, because that's what we do. We factor that top diamond number right here, that -10. So I'm going to make a -10 list over here. And my bottom number is negative, so my big number is negative. So 1 and -10, 2 and -5. Which ones are going to have a difference of 9? -9 is 1 and -10. So we're going to have a 1 and -10. Well, now we've got to divide by those numbers right here that we wrote down. 2 and 1. Factors of A. So the 10 is going to divide by the 2. The reason we don't divide the 1 by the 2 is because it would give us a decimal answer. And we do not want decimal answers here. So that means the 1 has to divide by the 1. Now here's the flip-flop. Whoever they divide by, they can't go in the same bracket. So the 10 divided by the 2, so he cannot go in this bracket. He must go in the other one. So -10 divides by 2 and gives us a -5. Again, he can't go in the bracket with the 2. This guy here is going to give us a +1. 1 divided by 1. And we fill in the other bracket. Okay. I'll give you a minute to write that down. I'm going to erase my other scribbles here. you've noticed on this example, the last example, there's a GCF. You can divide out. So as we said, there's a GCF, and GCF is 3. We're going to divide a 3 out of every term. So I'm going to do just my work above. So when I do that, I'm going to end up with x squared minus 3x minus 10. Now I'm going to factor what's in brackets. That 3 outside is no longer part of my equation that I'm factoring. So this is now going to become 3 and 2 brackets. But I need to do the diamond on negative 10. So negative 10, negative 3. Well, we already did our negative 10 down here. And we're going to see that 2 and negative 5 have a difference of negative 3. So 2 and negative 5. Our x only has a 1 in front of it, our x squared. So we don't have to divide anybody by anything. So now we're just going to put our numbers in our brackets where they go. And the numbers on my wings that I just wrote down are the ones that go in my brackets. Doesn't matter the order. I have a positive 2 and I have a negative 5. Okay? And that would be my final answer. Yes?
So even for like the third one, that would be your final.
Oops. Okay, carrying on. We have an equation. We want to find out all the information we know about this equation. Well, in order to do that, we need to figure out if we can find out the x-intercepts. We can only find the x-intercepts if we can factor it. Okay? We can graph everything and find everything on our calculators. But this wants us to know what can we determine just by looking at the equation and what can we tell about the graph just by looking at the equation. Well, let's take a GCF of what number should come out. What kind of 2? Negative 2. We're taking a negative 2 because the x squared is negative. Okay? You always want x squared to be positive when you factor it, so we're dividing out a negative. So we're dividing negative 2 as our GCF. So we would have x squared plus 7x plus 10. Okay, again, that's going to equal 0. So, what 2 numbers multiply to 10 and add to 7? 5 and 2. So, we're going to factor into 2 brackets, x plus 5, x plus 2. It does not matter the order they go in. We would have done a diamond on the inside there. We just did a few diamonds with the positive 10. So hopefully you were all remembering just a few moments ago that a diamond with a positive 10 and a 7 on the bottom, the only numbers are going to be 2 and 5. Okay? So what does this tell us about our graph? So what does the negative 2 tell us? There's a couple things he tells us. What does the negative sign tell us? What does the negative sign tell us? It's going down. Okay? So, the negative 2 tells us 2 things. First thing it tells us is we have a down graph. We sure do. It is pointing down. What else do we know? It's narrow. Perfect. It's narrow because the digit is larger than a 1. Without the negative there, of course. Alright, so so far we know it's down and it's narrow. We also know where it touches our x-axis. So, these, when they come out of brackets, are the x-intercepts. So, my x-intercepts are negative 5 and negative 2. So I already know where it touches x. Negative 5 and negative 2. So I know my x-intercepts. Are we able to find the y-intercept? Yes. But we have to do it with bedmass. So to find the y-intercept, we multiply every digit we see in factored form. So that means I'm going to take negative 2 times 5 times 2. And that's going to give me my y-intercept. Negative 5 times, negative 2, pardon me. Negative 2 times 5 times 2. My y-intercept is negative 20. Okay? So I know my x-intercepts and my y-intercepts. I can also find my axis of symmetry. from the equation. Okay? My axis of symmetry is going to come from my x-intercepts. Remember, all we have to do is add the x-intercepts and divide by 2. That tells us the middle of our graph. So the axis of symmetry is the x-intercept plus x-intercept all divided by 2. So that's going to be -5 plus -2 all divided by 2. We have to add the top first always. So -5 and a -2 gives us -7. -7 divided by 2 is -3.5. So we know the axis of symmetry. Okay? We also know our domain, XCR. We just don't know our range yet because we don't have our maximum point. So we know everything about this graph except for its maximum point. Okay? So that's the only thing we have to actually find from our from the calculator. So right now, to sketch this graph, we have he's touching -2, way down here at -20. He's touching -5. Okay? And the axis of symmetry that cuts this graph in half is at -3.5. That's our axis of symmetry. It's part of our vertex. 3.5 comma something is our vertex. Okay? So right now I know my graph comes up, changes direction, and does this. Okay, hopefully you draw better than I do. That was terrible. Okay, let's try that again. It's going to go up, he's going to peak up here, and then come back down. Something like that. Okay? So we know this much about our graph. All we've got to do now is find our maximum point. Okay? So at this point, this is when we go to our calculator. And now we're going to put in the entire equation. So in your y equals, we're going to put the original equation. We don't have to put the equation that we factored. So we're going to have -2x squared. And then what did it have? -14x, -20. Okay. Now when we graph it, we're going to see exactly what we just saw. Okay? So this is exactly the graph we drew. All we've got to find now is this top point up here, okay? So how do we find our max and min? What do I push on my calculator? Good. Second trace, min or max? Which am I finding? Maximum. He's as tall as he goes. So second trace, number 4, maximum. Now, you have to be to the left. Always watch your X and your Y down here. That tells you where your cursor is if you can't see it. So I need to be to the left of the highest point, always left. Then I need to be to the right of the highest point. Pardon me. Enter. Oh, hang on, I gotta start over. Second trace, number 4. So left of the highest, enter. Now you go to the right of the highest point, enter 2 times. So now we've got -3.5, which we found. And the next number that our maximum point was that goes to our range is 4.5. Okay? So the last thing we have to state is this number up here is a positive 4.5. Our range is going to be y, has to be smaller than or touching 4.5, which is our max. Okay? And that is how we solve our first question. So there are many things that we can find just from an equation about the graph. And we can sketch the graph before we even use our calculator. We only needed to use our calculator to see how high it went. Everything else we knew about this graph. All right. Let's try the next one. Okay, we're back at it here. On the next couple examples, we will do this example together. All of these, we just graph in our y equals, okay? We're going to do what we did last time. We're going to find out everything we know about the graph. So we want to find x-intercepts. We want to find y-intercepts. We want to find the axis of symmetry. We also want to find the vertex. we need to find our domain and our range and max or min. That's what we need to solve for each of these, okay? Now, you guys are very, very good at doing charts. This is like a chart without a chart written in it there for you. So all you've got to do is throw this in your y equals. You can answer almost every one of those questions, okay? I'm going to go to the next question. You're going to have these two for homework. We're going to go to the next one for the moment. This question. This is where we were in our last lesson, where we had to solve for the a value. The last time, though, it gave us our picture of the graph, and it also gave us our vertex, which was our max or min point. This time, we're not given a vertex. We're not even given a picture. All we're given is our x-intercepts and a point. Now, when we're given x-intercepts and a point, we don't go to vertex form. We're not going to use this form right here, a x minus p squared plus q. Because the question we always get is, how do you know which formula to put it in? Well, it's the information they give you. Right here, we have the zeros, which are the x-intercepts. If they give me x-intercepts, I'm not using vertex formula. They are giving me x-intercepts, so I'm using factored form, which is y equals a x minus m x minus n. Now, this is just the generic form of writing a factored equation, okay? You could also see this as R and S. They use different letters. Just like with PQ, they use H and K. They just choose different letters for different books. So, we're going to put the numbers where they belong. They gave us another coordinate point on purpose because we need numbers for X and for Y. And that's what we're going to use the other coordinate point for. They're going to become our XY numbers. So the 3 is an X number, and the 16 is a Y number. Now, this is where we have a coordinate bracket. This is a coordinate pair. Even though I'm taking them out of the brackets, they're not in a bracket with an X. That means they don't change their signs. They come out the same. So, B, the X is 3, so I'm going to put a 3 where the X is. Where the Y is, I'm going to put a 16. Now I'm going to go in, and I'm going to put in my x-intercepts. Now when it tells you your x-intercepts, that tells you exactly where it touches the graph. It has to go into the equation opposite. So that means this touched positive 7, it's going to come down, positive 1, negative 1. Positive 7, negative 7. Okay, that's where they go opposite in the brackets. Now it's just that next. We have to solve these two, and then they're sitting side by side, which means multiply. We're going to multiply. And that becomes the coefficient of the number in front of A. Okay, so that's the number in front of A. So let's do our bed math. So we're going to have 16 equals A 2 times negative 4. How big is 2 times negative 4? That's a negative 8. So we have a negative 8 A's. So at this point, this is where we're down to our last step. We're just going to divide by negative 8. Divide by negative 8. A equals negative 2. So now we put it back into our equation. But it wants general form. So we're going to have to FOIL here in a moment. So the equation was factored form to begin with. This one right here. So A is negative 2. I put it where the A goes. I have my X's back as X's. I put my X-intercepts back where they go. Negative 1 and negative 7. That's my equation, but that's the factored form. It said write the general form. All it wants for general form is for us to FOIL this, get our answer, and then multiply everything by the negative 2. Okay? You multiply everything by the negative 2 last. So, this is the way it's going to look. I'm an area boxer, so I'm an area box. So, we're going to have an x at a negative 1, an x and a negative 7. Here, I'll just pull this down a little bit so you guys can see it better. So now, x times x is x squared. Negative 7 times x is a negative 7x. Negative 1 times x is a negative 1x. Now we're going to get a negative times negative is a positive 7. Now we're going to look for like terms. Like terms are always diagonal from each other in this box format. So now I'm going to add it up. So this now becomes y equals negative 2. Now I put what I have left in there. X squared minus 8x plus 7. Now we're not done. It's not general form yet. Our last step is to multiply the negative 2 into the bracket, because it didn't want our answer in factored form. It wanted it in general form. So we're going to get y equals negative 2x squared plus 16x minus 14. Okay? So how do we know if we did it right? This is the question. So we're going to put it into our y equals 2 different ways. If we did it right, that means this equation here is going to be identical to that one there in our calculators. So I'm going to put the first one into y1. I'm going to put the next one into y2, and I'm going to make it a thicker line. And if I only see one graph, that means the other one traced on top of it, which means it's identical. And that's what we want to see, is only one graph. So going to our calculator now, we're going to stick in the numbers. So our first equation in the y equals, I'm going to clear out, and I've got negative 2 bracket x minus 1 bracket x minus 7. Okay, and down below, I am now going to put in negative 2x squared plus 16x, oh, not 46. 16x minus 14. Okay, at this step, as you can see on y2, I made it a thicker line. Now, when I hit graph, the graph itself, it's going to graph y1 first always, then y2. y1 is a thinner line, y2 is a thicker line. It's going to go really fast, so you have to pay attention when I hit graph. Okay, so one covered the other guy identically. So in the end, I only see one graph. That means they match. That means I did it right. Okay? So that is how we find a general equation given x-intercepts that we have to solve for a first. So this is a multiple step equation. Okay? Moving on to the next one. This is yours to practice identically. Same steps. Push pause now and play when you're ready. Okay, you've had a few minutes to take a look at this question, so let's see how you did. Please take your notes and follow along. So on this question, we are given the zeros, so that means we need to use the factored form, which is y equals a, x minus m, and x minus n. So, who are the x and the y? That is our point C here. So, we know our m and n. When they go back in the brackets, of course, they will do opposite sign. So, I'm now going to start with my negative 60, who is my new y number, equals an a value, bracket. And now I'm going to have 6 is my x value for my point, and now my x-intercepts are going to go in opposite sign. So my 4 is going to go in as plus 4, my 2 will go in as a minus 2. So now we've got negative 60 equals, we need to do bedmass. So our a stays a, we have a 10 and a 4. Now we're going to multiply again, doing bedmass. Negative 60 equals 40. A dividing by our 40, a equals negative whoa, negative 3 over 2. So, if you have an exact value answer, which this is, you can actually say negative 1.5. But we're not done the question. It wants us in general form for my equation. So that means now that I know my A value, I go back and put it into this equation, and then I need to do my foiling to figure out my new answer. So it's going to look like this. Y equals negative 3 over 2. I'm going to keep the fraction. And then I've got x plus 4, x minus 2. So the first step is to actually FOIL what's in your brackets. So I'm an area box person. I like to area box. If you're a FOILer, go for it. X and 4, x and negative 2. You should already have this done, of course. Negative 2x and negative 8. This gives me what's going to now be in my bracket. So I'm going to have y equals negative 3 over 2. That stays. And now I can write down what I have in my brackets there. So I ended up, from my area box, I have my x squared. I'm going to add my like terms diagonally and get positive 2x and negative 8. Now we're not done. We're almost done. We have to make sure we multiply our coefficient into the bracket. We have to remove the bracket. That's when it's completely in general form. So y equals, and in your calculator, because we're dealing with decimals, I'm going to take a look, and the first one's not so bad, because all I need to do is I need to take, there's a hidden 1 in front of my x squared. So that's just going to give me negative 3 over 2x squared. But now my negative 3 over 2 is multiplying by a positive 2. So in my calculator, you're going to put negative 3 over 2. You can put it as negative 1.5, and you're just going to times it by 2. Now you could also use your brackets, negative 3 divided by 2, again, and then times by 2. That also works. You'll get the same answer. So this is going to give us a negative 3x, and I would do the same thing with this negative 8 multiplying in, or multiplying by the negative 3 over 2, and that'll give me actually a positive 12, no more fraction. So my final answer in general form is finally negative 3 over 2x squared minus 3x plus 12. Check your work and make sure they match. I'm just going to back up a couple steps here to a couple pages before. You have these questions to do and to fill out both of those. So we're going to answer every one of these questions for both of these. So X-intercepts, Y-intercept, axis of symmetry, our vertex, the domain, and range, and our min-max. So from the example, you are going to get X-intercepts of negative 2, 0, and 5, 0. Please write them as a coordinate point. Y-intercept as a coordinate point is 0 and negative 5. We need our axis symmetry from our vertex. That's going to be x equals 1.5. Our vertex is 1.5 and negative 6.125. The domain, XER always, so I can go over to the right and just fill that in. Now our range, I'm going to have a y. Now again, my arrow's going to point depending on whether it's an up or down graph. This one, the graph is upwards, like this. That means my arrow's going to point to the right. So negative 6.125 comes down here from the vertex, and that's also our min point, negative 6.125. Let's take a look at how you did on the next part. Okay, check your work from the first one, make sure it's correct, it matches. On the second one, this guy here, let's put it as vertex first. He's got a vertex of negative 1.5 and 15.625. Now, from that vertex, I'm going to find my axis of symmetry, negative 1.5, and I'm also going to go down to my range and my max point. It's going to be a maximum because my graph is going down, and my maximum is going to be 15.625. So now in my y value, I'm going to point my arrow the opposite direction. And it's going to be 15.625. Going back to our y-intercept above, we're going to have a y-intercept of 0.10 that we get right from the equation here. And then our final two x-intercepts. We're going to have -4, 0, and 1, 0. Check your work, make sure it matches. This concludes lesson E.
Yeah.